Hi everybody, welcome to week 6.3 for chemistry home-based instruction. Today we're going to be talking about Gay-Lussac's law and the combined gas law. Under Gay-Lussac's law, we are only focusing on pressure and temperature changes. That means that the volume of the gas and the amount of gas molecules are going to be the same. So if you look right here, you see that volume 1 is equal to volume 2, and number of molecules at the beginning is equal to the number of molecules at the end. So we're not changing the space that the gas is in, those are the same, and we're not changing the amount of the actual gas molecules. So what we're going to be changing is the temperature, and that also changes the pressure. If you increase the temperature, you're going to increase the pressure because you make these gas molecules start to speed up whenever you heat them up. Well, if they're moving faster, they're going to bump into each other and to the sides of the container more often, and that's what's creating the increased pressure. Okay, if you cool down a gas, you're going to decrease the pressure. If you've ever seen a can of spray paint, it might say caution, contents under pressure, and you're not supposed to put that in really high heat, okay, because if you heat it up, the pressure is going to increase and you can cause that gas can to probably pop. So if you look over here at our equations, it's saying if you double the temperature, you're going to double the pressure, okay, because this is a direct relationship. Whenever you're doing these types of problems, make sure that your pressure units are matching. That means if one pressure is in ATM, the other pressure needs to be in ATM. If one pressure is in torr, the other pressure needs to be in torr. If they are different, make sure that you pick one and convert it to the other one. You can use last week's notes to help you do pressure conversions. Okay. Temperature has to be in Kelvin, okay? So if it's giving you Celsius in the problem, make sure you add the number 273 to it to put it into Kelvin first. Here are all of your equations that you're going to need, okay? This is how you solve for pressure 1, temperature 1, pressure 2, and temperature 2. Okay, now for the combined gas law, it actually takes all of the gas laws that we've looked at and combines them into one formula. So it has Boyle's law, Charles' law, and Gay-Lussac's law all together. Okay, so just like before, pressure units have to match, temperature has to be in Kelvin, and then whenever you're solving for these problems, there's more variables involved. So you do need to use parentheses in the calculator to show the order of operations. Okay, so if you're solving for P1, here's our equation for P1, you're going to take pressure 2 times volume 2 times temperature 1 and make sure all of that is in parentheses. Then you're going to divide it by parentheses volume 1 times temperature 2, closure parentheses, and hit enter. Okay. If you go to these different YouTube videos, there's some examples of different labs that we would have done in class if we were there. So if you want to check those out, it gives you more explanation on the laws, and it also shows you some of the cool demonstrations that we would have done. Okay, so here's the first example problem. This is the Gay-Lussac's law problem. Okay, so as we read it, it says a gas has a pressure of 50 millimeters of mercury at 540 Kelvin. Okay, so this is your first pressure and your first temperature. What will be the temperature if the pressure goes down to 3 millimeters of mercury? So that's your second pressure. It wants to know what the second temperature is. So what you do is you ask yourself first, do the pressure units match? They're both in millimeters of mercury, so yes. Is the temperature in Kelvin? It is. Now you can plug those numbers into the equation to solve for T2, which is P2 times T1 divided by P1. So plug in your numbers and solve. Your answer will already be in Kelvin. Okay, a gas cylinder contains nitrogen gas at 10 atm, 20 degrees Celsius. So this is your first pressure, this is your first temperature. The temperature increases to 50 degrees Celsius. What is the new pressure? Okay, so we're looking for pressure 2. Now ask yourself, is the temperature in Kelvin? No. So we need to go back and add 273 to the Celsius to turn it into Kelvin. These are the new numbers that we're going to plug into the equation. Find the right equation solving for P2, plug in, and solve. Your answer units are going to be the same pressure units as the pressure units given to you in the problem. So because they used ATM over here, we're going to put ATM as our answer. All right, now this is an example for the combined gas law. We have all three variables, pressure 1, volume 1, temperature 1, and then pressure 2, volume 2, and temperature 2. So if we read, we have 2.9 liters of a gas. Liters is the volume, so we plug that in here. Pressure of 5 atm is here, and a temperature of 50 degrees Celsius right here. What will be the temperature of the gas? So we're looking for temperature 2. If I decrease the volume of the gas to 2.4 liters, again, liters is a volume, and the pressure to 3 atm. Okay, so here's your second pressure. Are the pressure units the same? Yes, they're both in atm. Are the volume units the same? Yes, they're both in liters. Is the temperature in Kelvin? No. So we have to add the 273 to get it into Kelvin. Look for your equation for temperature 2, plug in all of your numbers, and solve. Make sure that you're putting parentheses in the calculator to tell it to multiply this section first and multiply this section first before dividing those two numbers. Whenever you solve, your temperature is already in Kelvin. Okay. Now, this is your last example for the combined gas law. As we're reading, we have an unknown volume of a gas. Okay, so we don't know the volume. The pressure is 60. The temperature is 115 Kelvin. Now they say they increase the temperature to 225 Kelvin. So that's your second temperature. The pressure is decreased to 22,800 torr. And this causes the volume to be 29 liters. Okay. How many liters did I start with? So we're looking for volume 1 because we don't know what we started with. Now, the first question you ask yourself, is the pressure units the same? If you look here, this one's in atm and this one is in torr. So no, they're not the same. So in my example, I went ahead and converted torr into atm, but you could convert atm into torr. It doesn't matter as long as they're both the same in the end. So when I converted to torr, I know that 1 atm equals 760 torr. Those are from the conversions from last week. So if I multiply it by 1 atm and divide by 760 torr, I get 30 atm. Okay, so I'm going to use that number for pressure 2. Find your equation for volume 1. Plug in all of your variables. Okay, make sure you use parentheses in the calculator. And go ahead and solve, and your answer will be in liters because the original volume was in liters and you want them to match. Okay, so that is all of the examples for the combined gas law and Gay-Lussac's law. And I hope you can get a good understanding of the concepts from this video and also from the videos on YouTube with the labs. Okay, see you guys next week. Bye.